All right, so yesterday we had just started talking about angle bisectors. Does anybody remember what a bisector does to an object? Yes, it's going to cut it exactly in half, making it into two smaller, equal-sized angles. So we see here on example number 4, it tells us that ray KN bisects angle JKL. Let's go find ray KN. Well, here's K, here's N, so this is ray KN here. And it is bisecting angle JKL. So we're going to go from J to K to L. So this blue angle here is JKL, and that pink line segment, or sorry, pink ray rather, that pink ray is cutting my blue angle into two equal parts. So this angle here, NKL, is congruent to this angle over here, JKN. It tells me that the measurement of angle JKN is 8x minus 13. So right down here, 8x minus 13 degrees. I'm going to add that to my picture, JKN. And then angle NKL is 6x plus 11. N over to K and up to L. So here's this angle, 6x plus 11 degrees. And what did we say we know about these two angles? They are congruent because this is a bisector right here, KN. So let's write down that those are congruent. Angle JKN is congruent to angle NKL. Because those angles are congruent, their measurements, so measurement of angle JKN, is equal to the measurement of angle NKL. When the angles are congruent, the measurements are equal. In the place of the measurement of angle JKN, I can replace it with this expression they gave me, 8x minus 13. I'm not going to write down the parentheses with the degree symbol on it. I don't need that while I'm solving for x. Equals, and then what would I put in the place of the measure of angle NKL? 6x plus 11, absolutely correct. Now I have an equation that I can use to solve for x. I need to get my x's to the same side, so I'm going to subtract 6x from both sides. What is 8x minus 6x? 2x. So I get 2x minus 13 equals 11. We want to get x alone, so I'm going to add 13 to both sides next. That gives me 2x equals what? 2x equals 24. And then we divide both sides by 2, and I get that x is how big? X is 12. Was that what I was supposed to find in this problem? No, what am I supposed to find? JKN, the measurement of angle JKN. Well, they gave me an expression for that. That was 8x minus 13. And we just did our solving work to find out that x is 12. So I'm going to replace the x with a 12. So 8 times 12 minus 13. And now I need to pop this into my calculator. What is 8 times 12 minus 13? 83. Now I am going to put the degrees back on this answer because degrees are a unit, and we just found the measurement of an angle. Whenever I find the measurement of an angle, I put the unit of degrees on my final answer. All right, so let's add that to the picture. This is 83 degrees. Well, if this angle here is 83 degrees, how big is this angle up here? 83 degrees. They didn't ask this, but how big would this big angle JKL be then? How would I figure that out? Measurement of angle JKL. This blue one, from J to K, from K up to L. So this angle here. How would I find that measurement? Multiply 83 by 2, or add 83 and 83 together. Angle JKL is made up of angles JKN put together with angle NKL. So we either have 83 plus 83, or you can do 83 times 2. So how big would that angle be? 166 degrees, yes.
So for problems like this, when we were doing we were substituting the x, did we need to put in the angle of JKL like you did like over there in the red?
Do you need to show that on the picture when you're doing the problem on the homework?
Not that picture. It's like further left, like where you do right in my hands.
This right here?
Yeah.
Well, it said to find the measure of JKN, so yes, you need to do this part.
Yeah, okay, I did it. It's just I didn't know whether we should show JKN for those parts.
JKN. Oh, you mean this side of it over here?
Yeah.
My preference would be yes, because sometimes I'm going to have you finding more than one thing, and that way you have your different pieces labeled so that I know which answer goes with which part. So yes, that is a very good habit to get into. Thank you for asking. All right. Before we do any more examples, we have to learn about 3 very special angle pairs. These are really, really, really important angle pairs. We're going to be talking about these for the rest of the semester and for all of next semester too. These do not go away. We'll still be talking about them in May. We need to learn how to recognize them and what we are looking for in the picture, and then how to identify them. If you look down at the bottom of the page, the first special angle pair is listed there for us. These are our adjacent angles. Adjacent angles have a common vertex and a common side. So they share a side. If you look at our picture here, we have an example and a non-example. So in my example, notice angles 1 and 2, that pink highlighted ray is one of the sides of angle 1, and it is also one of the sides of angle 2. So here is my shared side. Because they share a side, they are called adjacent angles. Over here with my non-example, the 2 angles have no shared side. So they are not adjacent. When they share a side, they are adjacent. If they don't have that side in common, they cannot be adjacent angles. We're going to flip it over now to page 5 to look at 2 more special angle pair types. And the first one that we look at on the top of page 5 is called a linear pair. A linear pair is a special pair of adjacent angles. It says the non-common sides are opposite rays. So the non-common, I need some more room for that. The non-common sides form a straight line. Non-common sides form a straight line. Because the non-common sides form a straight line, the sum of the angle measures is 180 degrees. So the 2 angles add to 180 degrees. If you look up at the top example here, between angles 1 and 2, we have a shared side right here. And their non-common sides would be this side right here on angle 1 and this side right here on angle 2. Notice that these 2 sides, when put together, form a straight line. And as I mentioned right here, because they form a straight line, when I know their measurements, I know they add up to 180 degrees. 45 degrees plus 135 degrees adds up to 180 degrees. So that makes them a linear pair. If you look at the non-example side, we have a shared side here. So they are adjacent. But they're non-common sides, here on angle 1 and here on angle 2. Those do not form a straight line. When I trace along those with my pencil, there's a bend or a curve. This is not a straight line. So they are not a linear pair. They are adjacent though. Because of that shared side, they are adjacent. But because their non-common sides don't form a straight line, they're not a linear pair. So that's two of the special angle pairs, adjacent angles, and then a special kind of adjacent angle called a linear pair. And then we have our last special type of angle that we want to talk about today, and that is vertical angles. Vertical angles are non-adjacent angles formed by two intersecting lines. So I think of these as opposite angles. When we say two intersecting lines, I mean that it makes an X. And vertical angles are congruent to each other. So if you look at our example side, I have one line here, one straight line. And then over here I have another straight line, forms an X. And so I have vertical angles in this picture. The vertical angles would be like angle 1 and angle 3, or angle 2 and angle 4. Angles 1 and 3 are vertical angles. 2 and 4 are vertical angles. Looking at this picture right here, we have a different X with a different numbering. And notice we have arc markings on here showing us that congruence. Angle 1 has 2 little arc marks on it, and so does angle 3. So angle 1 is congruent to angle 3 because they are vertical angles. Angle 2 has 1 arc marking on it. Angle 4 has 1 arc marking on it. Notice how they are opposite each other. They're on opposite sides of the X. Angle 2 is congruent to angle 4 because they are vertical angles. Over here on our non-example side, this does not form an X. So we have no vertical angles here. If you have lines coming together and it's not two straight lines forming an X, it's not vertical angles. Just sit up for me, dear. You're welcome. All right, I want to practice identifying some of these special angle pairs, and then we're going to use some of these special angle pairs to solve problems. All right, so looking down at the bottom of the page, we have example number 5. And the first thing I notice about example number 5 and this lamp is that it's formed by two intersecting metal bars. We've got one metal bar right here, and then we have one metal bar right here. Does it form an X? Yes, it does form an X. It's two intersecting straight lines. Because it forms an X, we're going to be able to find vertical angles in this picture. All right, let's start off with adjacent angles, though. That's the first kind that we talked about. How many pairs of adjacent angles do we see in the figure? And then we're going to list two pairs. So I'm going to walk through and we're going to look at our adjacent angles, our touching shared side angles, and we're going to count how many pairs we have there. So this angle right here, ABE, and this angle right here, EBC. Do you guys see how they share this side right here? That makes them adjacent angles. All right. EBC, this angle right here, and CBD, this angle right here. They share this side, so they are adjacent angles. So there's two pairs right there. Angle CBD and angle CBA. They share this side right here, so they would also be adjacent angles, so that's three pairs. And then the last one here, we have angle ABD and angle AEB. They share this side right here. So we have four total pairs of adjacent angles. And we were asked to list two of them. So let's go find two that we can list out for this. Let's start with this angle here. What would the name of that angle be? ABE. Angle ABE. And now I need an angle that is adjacent to that so that it has a shared side. It either has to share this side here or it has to share this side here. What would be a possible angle that would be adjacent? EBC. If you said EBC, that would be adjacent. ABD is also adjacent. I'm going to go with this one since that's the first I heard. EBC. Angle EBC. All right, so those are adjacent angles. Let's look at this angle this time. What would the name of that angle be? CBD, or we could call it what? DBC. Yep, angle CBD. And give me another angle that it would share a side with. It either has to share this side or it has to share this side. DBA would be one. Yes, that's the first one that I heard. The other one would be EBC. But DBA is the first one that I heard, so that's what I'm going to write down. Angle DBA. All right. Identify two pairs of vertical angles in the picture. Do vertical angles share a side? Vertical angles do not share a side. They have to be formed by an X. I asked this at the beginning. Do these two lines form an X?
Yes.
Yes. All right, let's do, this is one of our angles. So angle AEB, angle AEB, and I need another angle up here in this picture that does not share a side with AEB. DBC, this one right here, yes, angle DBC.
They don't share sides.
Correct. They do not share a side. Angle AEB and angle DBC. All right, so we did the top angle and the bottom angle. The only other direction that I can go now is left and right. What would be a vertical angle to this one? ABD. This one right here. So EBC and ABD. Angle EBC and angle ABD. They share a vertex, but not a side. That's right. They share this point right here where they come together in the middle of the X, but that's the only thing they have in common. All right. How many linear pairs do we see in this figure? What do linear pairs have to have? Yes, they have to be adjacent. They have to have a shared side. And together, their non-shared sides have to form what? 180 degrees, a straight line. Because this figure, this desk lamp, is formed by two intersecting lines making an X, all of my adjacent angles are also linear pairs. How many pairs of adjacent angles did we say we saw? 4. So there are 4 pairs of linear pair angles. Let's go through and name those 4 pairs. I already have 2 of them from when we did our adjacent angles up here. So let's go ahead and recopy those. ABE and EBC. Yeah. CBD, angle CBD and angle DBA. There are 2 more pair that we need to list. Let's go through and look at the ones that we've already listed. ABE is this angle right here, and EBC is this angle right here. So we've already listed that pair, the top 2 angles there. And then we have angle CBD, this one right here, and angle DBA, this angle here. So the 2 on the bottom. So we have the 2 above this bar, and we have the 2 below that bar. What other directions do I have other than above and below? I've got left and right. Let's name our left and right angles. Well, I know this one's on the left side, angle ABE. What would make a linear pair with that would still be on the left-hand side? DBA, yes. This angle right here. They're both on the left side of this post. So angle DBA. All right, we've done top, we've done bottom, we've done left. Now we need to do the ones on the right. What's this angle right here? EBC. So we have angle EBC. And what is another angle on the right-hand side that forms a linear pair with EBC? CBD, this one right here. Angle CBD. Very nicely done. All right, there's 2 more things that we need to find on this before we move on. We need to find the measurement of angle EBC and the measurement of angle ABE. There's only one measurement on the picture. What is it? 138 degrees. This angle right here, angle ABD. Angle EBC is this one right here. What kind of angles are these 2, ABD and EBC? What do we call that pair? They are congruent because what's the special name for that pair? Vertical angles, yes. Those are vertical angles, and vertical angles are congruent to each other. So how big is EBC? 138 degrees, yes. Measurement of angle EBC is 138 degrees. And then we want to find the measurement of angle ABE, this one up here. Well, what did we say the relationship between these two were? What was the name of that special angle pair? These two.
ABE and C.
Yep, ABE and EBC.
Yeah,
They're a linear pair. These two right here, ABE and DBA, those are also a linear pair. What's the relationship for linear pair angles? It's up at the top of the page.
They add up to 180.
They add up to 180 degrees, yes. All right, so the measure of angle ABE together with plus the measurement of angle EBC is 180 degrees. And we just wrote down on the previous problem that angle EBC is how big? (138 degrees). Well, what would I need to do now if I wanted to find the measurement of angle ABE? Subtract. Go ahead and subtract 138 from 180. 42. So this angle is 42 degrees. They didn't ask for this, but what other angle in the picture would also be 42 degrees? CBD, this one down here, that's a vertical angle to ABE. That one is also 42 degrees. We want to mark our picture all up. Everybody should have their picture marked up with all of these angle measurements and how we found them. I need you to stay with me, honey. This is really important information. Really, really important. All right. We're going to flip over to page 6. We're going to look at question number 6. A city planner is designing a park right here. He wants to place 2 pathways that intersect near the center of the park, like this. If the measurement of angle GED, well, here's G, up to E, and then over to D. So this angle right here is 88 degrees. So we have this here, 88 degrees. Identify the true statements. Well, how big would this angle be up here? Let me find a different color that'll stand out. This angle up here, how big would that one be if this one is 88? Would also be 88 degrees. Yes, it's congruent, so it is 88 degrees. Is there a statement over there that says that? Which one? C. Angle FEH is 88 degrees. All right. Let's talk about these other 2 angles. What's the relationship between GED and this angle up here, DEF? Yep, they're adjacent and they're a linear pair, which means they add up to 180. So the measurement of angle GED plus the measurement of angle FED is equal to 180 degrees. We know that GED is 88 degrees. So now I'm going to minus that from 180 to find angle FED. What is 180 minus 88? 92 degrees. So up here, this angle is 92 degrees. What other angle in the picture would also have to be 92 degrees? GEH. This one down here is a vertical angle to angle FED up here. All right, let's see if there's any true statements about my 92 degree angles. A. Any others? Are any of the other statements true? That's all of them. Those are all the true statements from that picture. All right, let's go look at question number 7 now. We're going to get a little bit more practice with naming and then identifying special angle pairs. First thing we want to do is identify the angle formed by ray XU. Here's ray XU. And ray XZ. Here's ray XZ. We want to name this angle in 4 different ways. What is one possible name for this angle? What is one possible name for this pink angle? UXZ. Angle UXZ. U to X and then all the way over to Z. Yes, not equals. Does the order on my letters matter? Not really, except for one letter has to stay put. Which one has to stay in the same spot? X, the one in the middle. So how could I use this name to write another name? ZXU, angle ZXU. X has to stay in the middle, but the first and last letter can flip around. All right, let's find another name for this exact same angle. Yep, YXU. Angle YXU, or you could call that what? UXY. Nicely done. All right, for part B, I want to know whether the angles that we are naming down here are vertical angles. Are they a linear pair? Are they adjacent, but not a linear pair? Or do we have no name for that special angle pair? So I'm going to highlight the angles that we're talking about, and we're going to try to pick out what type of angles those are. So YXU, this angle that we were just looking at, and angle UXW, this angle here. So I want to start off with, do they have a shared side? Because if they do, they're either adjacent or a linear pair. Yes, they share this side right here. So at the very least, they're adjacent. Do their non-adjacent sides, this one and this one, they're non-shared sides, do those form a straight line? No. So what kind of angle pair would this be then? Adjacent.
So linear pairs, they form the opposite sides, not the opposite sides, but
the non-common or non-shared side has to form a straight line. This is adjacent, but not linear pair. All right, let's look at the next pair of angles. We have angle XYU, this angle right here, and angle ZYU, T, this angle right here. Do those two angles have a shared side? Is there a side that is marked with both blue and orange? No. They don't have a shared side, so they're not adjacent angles, and therefore they can't be a linear pair because there's no side that's shared by both of those. Do they have anything in common?
No. We only have the vertex in common.
They only have the vertex in common. Is it formed, are these two angles formed by two straight lines making an X shape?
Yes.
Yes, right here and right here. And they have that vertex where the X comes together in common, which means this is what type of angle pair? Vertical angles. All right. Next angle pair to look at, we have TYZ, this right here, and XYT, this one right here. Do those two angles have a shared side? Yes, right here. TY they have in common. Do their non-common sides, this one and this one, form a straight line? Yes, which means this is what special angle pair? Linear pair. All right, last one. WXU, this angle right here, and XYU, this one right here. Do those two angles have a shared side? No. Are those two angles formed by two intersecting lines forming an X? No. Then they can't be vertical angles, which means what? No name. All right, there's still some more examples that I want to do with you guys before you turn in your homework. I would like to do example number 8 and then all of the problems that are on page 7. So because of that, I'm going to push your homework back a day. You're going to have an extra day with your homework assignment. It will now be due on Thursday. Homework is due on Thursday.
I did the third case of